guess after this we can try to work it on the computer and see if we can get the rest of it working. Is this the first slide?
No.
Okay, before we get started, I want to make a few quick announcements. First up, this is the last week of regular seminar. So after today's lecture, I want to actually give you guys the instructions for the presentations we're going to make next week. So, you know, make sure, stick around, maybe take 15, 20 minutes to do that. And also, I'm going to send you guys an email about doing the teaching evaluations for the class that needs to be done, you know, bookkeeping stuff. And, let's see what else. Another thing is, if anybody has any reports that are out that are still being due, that you haven't turned in yet, I will accept those up to next Monday. So if I don't get them by Monday at the final presentations, then that's it. So if you're still behind on any, I need to get those from you guys. All right. Let's see. I'd like to turn over to our speaker. Did you want to introduce? Say a few words?
I could. Thank you.
Okay. Well, I'm going to introduce our introducer first.
All right. Do I need to turn this on?
No. Just leave that on.
All right.
This is Milijana. She has she's been an adjunct professor here at UH Clear Lake, teaching astronomy.
Actually, astronomy was mine.
Anyway, and she's here to introduce our guest speaker for today.
And this is Dr. Steve Alexander. He's the physics department chair at Southwestern University in Georgetown. And I would like to say that put some serious efforts to improve quality and experiences of undergraduate physics program at his institution. So he's going to give you a little talk about some of the efforts that are done at Southwestern University.
All right. Well, thanks for inviting me to come down here. So just to give you a little bit of context, so Southwestern is a private liberal arts school up in Georgetown. We've got about 1,500 students, and of those 1,500 students, roughly, let's say 100 students take physics every year. And one of the great things, I guess, about being science education kind of students is you'll kind of quickly learn that everybody needs somebody to teach first year physics. So it is basic to chemistry, biology, as well as physics, engineering. So there's always going to be a need to teach this subject and to teach it well. The first year physics is kind of a core course for the MCAT. And so of the 100 students that are taking the class every year, most of them are not going to be physics majors. In fact, most of them are going to be chemistry and or biology majors who eventually want to go ahead and go into medical school. So they're taking this as basically a prep for the MCAT. So one of the things that's challenging about teaching first year physics is we have students who are in their very first semester of college life. They may not have taken physics before in high school. They may not have had calculus before in high school. And then we've got the junior student who is trying to balance physics with biochemistry and everything else, as well as the occasional senior. So the kind of the level of student that we have really varies over kind of a wide margin. So part of kind of what I'm going to talk to you today is just to kind of explain, and that's context for why we've been trying some of the experiments that we have. And of course, you know, with all of this, data is going to be kind of very important in trying to understand whether what we do actually makes sense. So as this slide starts to explain, 2013, Southwestern was kind of lucky enough to get a Howard Hughes grant. One of the purposes of the grant was to start getting people on campus more involved with active learning and all of the different science classes that we were teaching. So there were lots of summer kind of workshops where we would talk about different types of active learning. We would talk with each other as faculty members about, you know, how we were trying to incorporate different things in the class, whether they were working, whether they weren't working. And everything kind of involved around the benefits of active learning. And I've listed 4 of them here. One of the reasons that we do this is it increases in retention, critical thinking, and collaborative skills, and more importantly, it kind of increases engagement. So students become more active, they become participants in learning the subject matter. So around this time, I was teaching, you know, what would be considered a conventional physics class. So what that meant was every week I would hand out homework problems, roughly 10 problems. There were 3 tests scattered through the semester. Homework was due kind of usually, it was handed out on the Monday, it would be due on the following Monday. And then the tests were kind of 1-hour tests. The students met for 3 hours once a week for lab. And then toward the end of the semester, we had a comprehensive final. And so all of that worked out to be about, you know, 100%. The final was roughly 10, 12 questions. They had 3 hours to do this. With the tests, a lot of times, because students were concerned about being rushed, one of the things that I did for a couple of years was try and hold night tests. Several of the other departments had this. That was kind of spotty because our students are very busy. Almost 1/3 of the Southwestern students participate in some type of athletic sport. Lots of others are very active in different social organizations, so it was always difficult to find a nighttime test when everybody could come and, you know, spend the 2 hours that I wanted to try and assign for all of that. So what that meant was that either we gave the test in class, in which case, you know, maybe out of a class of 50, 5 or so, 10 students maybe felt like they really could have used more time to answer 10 questions, or we went ahead and scheduled it at night, and out of the 50 people who were taking the test, maybe 20 or so couldn't be there in the evening because there was some other school-sanctioned event that took place. So there were lots of problems trying to kind of keep all of the people happy. So one of the kind of guiding principles for first-year physics that I've tried to kind of keep in mind is that if you, for each week, you know, I would go ahead and post a series of practice problems so students could begin to test to see whether they understood the material. If they understood the material, then that would help them to do the homework. Then if you can do the homework, you're ready to do the tests. If you can kind of understand what was on the test, then you're ready to go ahead and take the final. So everything kind of builds, as you know, on being able to solve different problems. The best way to solve problems is just to start working lots of different types of problems so that you become more comfortable with the different nuances of all of the different topics that we would normally cover through the course of a semester. So part of, you know, what I was kind of seeing after many years of teaching physics in this way, and, you know, we're talking here easily 20 years or so starting at different institutions, the same things would come up kind of semester after semester. I would have sign a book, and of course the book is too expensive. We would be using an older version of the book so that it wasn't really as expensive as paying out $300 for the very, you know, most recent edition, which doesn't really make a lot of difference in what we were teaching. So normally we'd be about 5 editions behind. So it was, you know, $100 for a year, but for some of our students, that was a lot of money. So some students didn't bother getting the book. Even if they got the book, they didn't read the book. So part of what the kind of problem that led to was that people would come in and during office hours, which is great. I welcome everybody to come in and talk to me, but part of what I would be doing in class is explaining kind of what the material was that we were covering for the week, trying to explain what was important, what wasn't important, but because they had no resource to kind of put that information into context, several people would come in after hours and say, could you kind of explain this again because I don't understand how to do the practice problems, which is fine, but anytime you have kind of the same kind of problem come up over and over again, it just usually means something has to be changed. So one of the other things is because I would go ahead and assign practice problems every week, I wanted to try and keep it at a kind of a fairly decent number so that students wouldn't be overwhelmed, which usually meant that there were types of problems or maybe just one problem involving a topic that we were covering. And if I asked then another variant of that problem on the homework or the test, nobody kind of understood then how it related to the practice problem. When I get to the test then, what I have to do is if I want to go ahead and say, all right, I want my average grade on this particular test to be an 80, for example. So I've got 10 questions, then I have to go ahead and kind of judge the quality of the questions or the hardness of the questions. They can't be too hard, they can't be too easy. Otherwise, everybody just takes all of the time to struggle to get this one particular problem. That leads to people not finishing the test, all of these kind of assorted problems. So making the test becomes kind of an experience where you're trying to see, okay, well, what can they do? What don't they understand? What should we be testing on? And sometimes you get it right, sometimes you don't. And I personally don't really like to curve tests. Occasionally what I would have to do is I would have to throw out questions because nobody understood what it was that we were talking about. And that was fine. But again, it's frustrating. You spend all that time kind of preparing just the right question and nobody appreciates it. Okay. There were also a number of particular problems again. And so this is something that crops up year after year after year. When I was in school, the faculty would go ahead and encourage people to get together, study, kind of talk out what the problem meant, and to work out different solutions. Fine, I really encourage that. We offer tutoring every week, multiple sessions for people who need to come in and talk about different problems. But occasionally I would notice that there would be a few people who had exactly the same kind of answer for a particular problem up to about 3 or 4 decimal points. It would be wrong, but it would be exactly the same. Then, of course, because the students are very busy, not everybody can turn in the homework when it's due. If the homework's assigned on Monday, if the homework is due the following Monday, I usually tried to get the homework turned back very quickly. And so part of what I would do for the grading would be to go ahead and give partial credit. So, do you understand most of what you're trying to do? Again, I communicate to the students, show the work. If you understand what it is that you're doing, and you put the number into the calculator wrong, but everything else is right, you'll get the majority of the points. Okay, so what I have to do then is, as I'm grading, I have to try and kind of make an estimate. Okay, is this mostly right, mostly wrong? Where does it fall on the point spectrum? And then after I turn back all of the homework, then I'll go ahead and post a key so that everybody can understand how I work the problem. And again, you can kind of use that to study for the test. Well, every semester there was going to be a couple of people who would invariably turn in their homework after the key had been posted because of stuff that they were doing. And so trying to deal with that became kind of a constant irritation. All right, the other kind of perception that I have is that once the homework was done, nobody really thought about it anymore. It's time to move on to the next thing, and then the only time that the homework gets pulled out is when you're studying for the tests. So is that really the best way to learn? Kind of a lot of cognitive theory suggests that you want to be exposed to an idea over a period of time, and then as you understand what it is that is correct, what it is that isn't correct, you start to do better and better in solving these types of problems. And so there was a kind of a feeling on my part that the homework kind of method wasn't working. So as part of the HHMI grant, one of the things we decided to go ahead and do was to kind of revamp everything. So we had two kind of sections of physics, so each about 50 students or so. And then we decided, okay, well, we're going to use one as a control group. So teach it the normal way, tests, homework, final, all of that sort of thing. And then in the section that I would go ahead and teach, we'd try something different. No homework, no tests. Instead of all of that, what we would do is we would offer a quiz over the material that we would cover for that week. And so, as kind of explained here, the quizzes are going to have a random group of questions. So no quiz is the same as another quiz. So don't really have to worry about two people kind of sitting down and answering everything together. They'll have different questions. And then because the quizzes are randomized, the students can actually take the quiz over again if they don't like the score that they got. So 14 weeks is kind of a normal semester for us. Each week has a quiz. Each quiz is going to have 5 questions. And so what I said was, instead of having the 50% of your grade come from homework and tests, now the 50% of your grade is going to come from these quizzes. And so you need to accumulate a maximum of 50 points for your total overall grade. And so that became kind of the experimental part of all of this. So in order to kind of then make this work, I had to do a couple of other things. So first thing I had to do is solve the problem of the students not reading the book. The students are always going to need some type of resource to go back to. So as kind of to take care of this particular problem, one of the things I did was I clarified a lot of the notes that I had made for myself about what should we be covering each week. And then I organized it into 4 or 5 different topics. So each week we would normally, as a kind of a matter of course, talk about 4 or 5 different topics. And so now the notes covered each of those topics individually. And the notes also had kind of just not only a short explanation of what it was that the topic covered, like, for example, the Doppler effect. So, you know, what types of things can you do with the Doppler effect? Where the formulas come from? But then there are also a couple of examples for all of that, a couple of worked examples. So the notes for each week then get put up online. The students have that now as a reference that they can use to follow along in class. In addition, now each week to the notes, we also have practice problems still. But now I went ahead and kind of set up the practice problems to mirror the notes. So instead of just having a list of 10 questions or so, now the practice problems say, okay, so for each of these topics, here's a couple of questions that give you an idea of what you can kind of expect for this particular topic. So everything was then organized around that. And then the last thing that I did was I created a formula sheet for the semester so you can get an idea of the, you know, the sorts of things that you're also going to be expected to learn how to use. And in addition, then I ended up creating a test bank. So for each of these topics, I went ahead and made up 10 different types of problems. Some were pretty easy. Some were kind of multi-part, so they would take a little bit more time. Some are going to be conceptual questions. So the problem or the concern that I had before, where trying to figure out, okay, if I want an 80, what sort of balance do I have to have in terms of the types of questions? All of that fell away because now it was completely random. So some quizzes are going to have, a couple of easy questions, maybe a couple of hard questions. Some are going to have, more conceptual questions, and it all just varies. For the quizzes, one of the things that I went ahead and did was then, so out of that test bank then, so 5 topics, let's say each topic had 10 questions that I went ahead and designed, then I generated 100 quizzes from that. So I randomly chose 1 question from each of the topics. And then, if a student wanted to take a quiz, you just hand off one of the papers and they start working on it. Each quiz has 5 questions, and again, because they vary in difficulty, I figured, okay, most students should be able to finish that in about 15 minutes. Let's see. This is kind of 2 examples of a quiz that we would give in the second week of class. So you can see that each question involves a different topic, and it turns out that in this particular case on the left and the right, the second question is exactly the same. That's okay. That turned out to be that way randomly. Everything else is a little different, and there are variations on the same type of problem. So for instance, this last one, we've got a 2-dimensional motion type of problem. Here, what I'm trying to do is to get the students to give me the components of the position. And over here, they're interested in the components of the velocity. So same skills, different types of problems. And, some of the problems involve trying to understand, do they understand the trigonometry that we're going to be using for vector addition, vector decomposition, and then the applications for that in terms of 1- and 2-dimensional motion. So there are 100 of these, and each week, students will come by and take those. This is a kind of an example of the notes that would turn out, that would be posted online for this particular topic. So this is just a review of trigonometry. Again, some students will have seen this. They'll be very comfortable with this. Other students really do need to be reminded about how all of the different trigonometric functions are going to be used in the context of solving these types of problems. And so we go through the definitions. Formulas here will be given on the formula sheet, but now what we're doing is we're putting everything into kind of the context of trying to solve these types of problems. And then we go through now 2-dimensional vectors, how we can go ahead and decompose them, how we can go ahead now and start to add them up again, and all of the different types of operations. And then there's okay, so this is, I guess, the 2-dimensional addition. Break everything into components, add the components, then if you want, you can go ahead and put them back into the magnitude and the angle form. And then a really short description of how you would do this with 3-dimensional vectors. So once you understand 2-dimensional, then hopefully 3-dimensional is relatively straightforward. So that's kind of a good example of the notes that would be posted online for this particular topic. And so when the students are trying to do these first 2 problems, they can go back to the notes in the practice problems and relate what's in there and what I've talked about in class to solving problems like this, so that when they get a copy of the quiz, then they're kind of ready to go ahead and try and solve one of these or both of these types of problems. All right, so once I decided on using quizzes instead of homework and instead of tests, I had to figure out, okay, well, what would this actually mean in practice? And so what I decided was that each quiz could be taken a maximum of 3 times. So this kind of prevents somebody from obsessively taking the same quiz over and over again until they get a perfect score. With 14 weeks of quizzes, you do not have to have a perfect score in order to reach the maximum number of points. The other thing that I decided just to make my life easier is the answers are either right or they're wrong. That makes grading really, really simple. I can kind of look at the answer. If the sign is wrong, for instance, if we're talking about the electric flux and they've got a positive value and it should be a negative value, it's wrong. And so then they can go ahead and take the quiz over again once they realize what it is that they've kind of done incorrectly. And then the kind of the most important thing is each quiz is only available for about 2 or 3 weeks. And so the idea here is you want to have everybody keep up with the current material rather than keep trying to solve the earlier stuff and ignore what's going on kind of in class. So we don't really want anybody to fall behind, but we do want to go ahead and let people kind of retake things once they've understood what it is that they didn't understand. And if you take the quiz again, there's no kind of downside other than you just have to spend the time doing it. It's the highest grade that's going to be recorded. So what some students will go ahead and do is they will go ahead, take a quiz, then they'll see how they did. If they get a 2 out of 5, then they'll try and figure out, okay, well, what is it that I didn't understand that I missed? Retake the quiz at another opportunity. And usually they do better. Quizzes can be taken during now the tutoring session. So one of the things that we've noticed since doing this is nobody comes in to ask kind of questions about the material anymore. So it used to be that people would sit in my office and say, explain this, I don't understand that. Between the notes, between what we talk about in class, that seems to be covered. What people come in to tutoring to do is just go ahead and take quizzes. So the tutors come in with stacks of quizzes, they will go ahead, hand them out, the students take the quiz, turn it back to the tutor gives it back to me, and then while I'm watching TV the next night, I'll go ahead and grade a whole bunch of them, hand them back. So it really doesn't take a whole lot of time. Some students, because they can't come in to the tutoring hours in the evening, again, think of athletics, think of all of the different things that are going on a normal college campus, then they can come into my office hours, or if I'm in my office, to go ahead and grab a quiz, take it, and then turn it back. If we go ahead and we finish the material for a week early, so I teach a Monday, Wednesday, Friday class. And so if on Monday and Wednesday we cover the 4 topics that we're supposed to cover for that particular week, then one of the things I will do with my class is I'll say, okay, Friday is going to be a quiz day. If you want to take the quiz for that week, for the current week, I will let you take that quiz with a partner. And so the 2 of you will then kind of can kind of talk about the problem, you can try and figure out what's going on, and then put both of your names down and you'll both get that grade. So that turns out to be kind of a good incentive, again, for everybody to keep up with the material, because now it's less intimidating to take the most current quiz by yourself, but if you're taking it with somebody else, you can kind of argue about, okay, where is the negative sign associated here? Is it here? What does this mean? Is it vector? Is it scalar? So they have somebody they can talk to about all of this. And again, if once they take the quiz, they don't like the grade, they'll come back later, take it over again by themselves. The 4th possibility for taking the quiz is that Southwestern has a testing center where students with documented learning problems can come and take tests. Normally, this is going to be extended time. And so if, again, a test is a 1-hour test and the student needs 2 hours, they can go ahead and make a reservation at the testing center to get that extra time. Sometimes they need a kind of an environment where there are less distractions. So the rooms will play white noise or some type of soothing nature music. So I've heard. If somebody sets up an appointment at the testing center, they want to take a quiz, perfectly fine. I'll go ahead and ship a copy of the quiz to them, and then they'll ship it back to me. All right, so kind of as we started doing this, a number of observations kind of quickly became apparent. One is that the students were using the quizzes to identify what they knew, what they didn't know. Again, sometimes with some of these problems, there are nuances like, you know, is something a scalar, is something a vector, that approach, you know, that will influence how you approach the problem. A lot of times with scalars, the sign of the problem is going to make a big difference, and so you have to kind of realize that in order to get the right answer. And so as a result of, you know, just kind of leaping forward, taking the quiz, seeing what they knew, what they didn't know, or what they thought that they knew, they were interacting with the material over a much longer period of time. So students would normally take a quiz, you know, over about 2 weeks, which seemed about right. And so then some students didn't need the 2 weeks. They would kind of solve the problem and then move on. But the students that needed the extra time got the extra time. And I didn't think that they would really have had that experience if we had stayed with the tests and the homework. As I kind of said before, lots of students have things going on in their lives, and so the test gave them a lot of extra flexibility. So if students were away, then they could go ahead and just take a test when they came back. So it wasn't kind of, we had to schedule everybody to be in one place at one time sort of thing. And then since a lot of the students are chemistry and biology students who are also taking organic, then, you know, if organic just gets crazy, they can concentrate on that for a week. And then once they're done with that, they can come back and now pay hopefully more attention to my class. So it lets students to go ahead and kind of figure out exactly how they wanted to arrange their time. So time, as you all know, time management is one of those important life skills that really becomes more and more important in college. Because they can retake the quiz multiple times, they're less kind of stressed about doing everything perfectly. And then, you know, there are going to be a couple of students who just try and put off everything for the very last, until the very last minute. So part of, you know, what this kind of causes sometimes is students to have to be more accountable to themselves. All right, one of the kind of the quotes then for the talk today actually came up last week when we were having a faculty kind of discussion. And so somebody had said, they were talking about kind of the evolving kind of demographics. More and more of our students we're finding are on some type of medication. And so, you know, somebody said in this particular meeting, if you design a building from the beginning to accommodate everyone, it's going to be a lot easier than retrofitting the building that's already been kind of in use for numbers of years. And that's kind of, when I heard that, I kind of felt, okay, well, that makes sense from the point of view of how we're delivering all of this information then to the students. So one of the nice things about the quiz method is if students do need to kind of work on something, then they can come back and take the quiz when they're ready. If they want to go ahead and take the quiz at the testing center, that's fine. We have great kind of camaraderie with the people in the testing center, so it's not a problem sending anything to them, getting anything from them. And again, the students feel very comfortable, I think, interacting with that. So the quiz method seemed to be kind of working better for me and for many of the students. And I think it's that flexibility that I think we all appreciate. So now the big question, of course, does it actually kind of work? I mean, there's got to be an educational Hippocratic oath where if you do something, it shouldn't screw up everybody. And so is that actually the case? So because this started off as part of a Howard Hughes grant, they're very interested in whether they're getting their money's worth. So everybody is collecting data, they're trying to analyze the data to see whether the active learning is actually paying off. So we've been collecting now data for several years. Much of it is not completely analyzed, but every year as a department, we have to turn in our kind of departmental assessment. And as department chair, that falls on me to kind of go through everything and figure out whether we've done anything useful or not. So as part of the data that we've been collecting, we have information about the demographics of both of the sections, the control section and the experimental section. How many men, how many women, first year, second year, so on. At the beginning of every semester, we administer a 42 or 24 question content test that's been designed by the American Physical Society. So it covers the material for first semester, second semester, and then we have all of that. Then what we go ahead and do is we have been giving the same final for each of the classes. Part of the final is going to be now 10 numerical problems, very similar to the types of problems they've worked on their homework or on the quizzes. 10 of the problems are going to be conceptual problems that turn out to be exactly the same as from the beginning of the year assessment. So we kind of pick out 10 questions that cover the material that we think we need to for the final. And the reason that we went ahead and did that was for years, what we went ahead and did was we gave the same assessment at the beginning of the semester and at the end of the semester. The problem is at the beginning of the semester, everybody's enthusiastic. They'll turn it in and they'll try and do their best. By the end of the semester, everybody's so tired, they just want to go ahead and kind of mark whatever answer they think is right without really caring whether it's the best answer that they can think of. So for many years before all of this happened, we were getting really strange numbers. And we kind of gradually realized that the students weren't taking the end of the semester test seriously, so we decided to go ahead and fold it into the final exam. As part of the final exam, it's going to make a difference on their grade, and as part of their grade, they are going to take it seriously. So once we started doing that, we got much better learning gains. Big surprise. All right, so this is kind of, I think, the first year. We had kind of the two sessions. The demographics are a little different. As you can see, more men in the control group, more women in the experimental group. There's also kind of some small differences in first year versus fourth year in each of all of that. And so we have now kind of a way that we could go ahead to kind of analyze to see how much difference all of that makes. What we found, though, is that if we look at the pre-assessment, so the 10 questions that they took at the beginning of the semester, and then at the end of the semester, you can see that there is a gain in learning, which is great, you know, good for us. We're actually teaching them something, and that there's a slight kind of improvement possibly in the control group than in the treatment group or the experimental group. If we go ahead and we kind of actually convert all of this into numbers, one of the things that we found is that there is, I guess, no difference if you look at the numerical part of the final, but if you look at the conceptual part of the of the final, then the control group, the normal sort of test and homework, did slightly better, and it seems to be significantly significant. So that's kind of, so that was for the fall of 2015. So we had run that kind of data more intensively than anything else. And so, you know, thanks to Milijana, to kind of try and figure out what it all meant. And then for subsequent years, we didn't go into that level of detail, but as part of our departmental assessment, we did have to go ahead and kind of tell our administration what the learning gains were. So what we've calculated for several semesters then is this learning gain, which basically is the difference between what they learned at the end of the semester minus what they learned at the beginning of the semester normalized. And so what you can kind of see here is that the control group averages around 50%. So that's not bad. The experimental group, for the most part, is a little less than that. It's usually kind of, there's usually more students in the experimental group. Again, how much difference that makes, hard to say exactly. There was this one semester where the experimental group got much better results than the control group. We're not quite sure maybe what happened in that one semester. Again, that's something that we're hoping that once we start digging into the data, we can identify that. Because the nice thing about everything that I've talked about here today is that we can go back and we can kind of tweak all of this. So if there's things that we need to add to the quizzes, to the notes, we can go ahead and include that sort of information. But for the most part, I mean, we're seeing that there's a little bit kind of smaller learning gain in the experimental group than in the control group. Whether that's turns out to be, it's probably statistically significant, but exactly why, you know, we're still hoping to find out. Okay, so that's my story. And of course, you know, I wanted to thank everybody here for listening to me ramble on. This work was supported by Southwestern and our grant from the Howard Hughes Institute. My colleagues Mark Batorf, Irina Marinova have taught in the control group, and so they're who I'm comparing against. Irina is kind of very good, and so it might be that this is teacher dependent. One of the things that we're doing this semester for the very first time is that we have no control group. So we have both sections now using the quiz method. So one of the things that we'll have in a little more than a week is we'll be able to look at the learning gains for the two sections. And so we'll start to kind of accumulate over the next year or so evidence of how much, you know, the teacher actually makes in this particular, how much difference the teacher actually makes in this sort of process. So that's one of the other kind of variables that we're going to try and suss out over the next couple of years. So we'll be using the kind of the quiz method for both sections, and we'll look at, you know, how different people then produce different learning gains. Is it going to be more or less the same? Is it going to be vastly different? Okay, if it is different, which you kind of think it should be, then what makes the difference? So hopefully all of these things, all of this evidence then, will lead us to kind of doing a better job of teaching first year physics. So stay tuned. Okay, thank you. It was self-selected by the students.
So that's why there's such a difference.
Yeah, and so my class is Monday, Wednesday, Friday. In order to maximize flexibility, the control group has always been a Tuesday, Thursday class. So they're meeting twice a week for slightly longer period, which of course, may have a little bit of an influence on all of this. Okay, yeah.
I just want to make sure, like a clarification, the quizzes that you were giving, they were like actual assignments that were factored in. They weren't just extra credit.
These are not extra credit. So for instance, this is, if you came in, this is what you would be given. And so this was, again, first semester, second week of class. You'd get one of these, you'd fill it out, I'd compare the answers to the key, and so you'd get back a score of, let's say, 3 out of 5. If you're happy with those 3 points, then you move on to something else. If you really, really want the 5, you can take the quiz over again. Yeah. Yeah.
When they take the quiz over again, are they getting the same version that they got the first time?
No, so each quiz is a collection of random selections from the testing bank. So first time you take it, this might be what you get. Second time you take it, this might be what you get. So in this case, yeah, one of the questions is the same. All of the questions are going to be over the same topics. But the question could be a numerical question, could be a conceptual question. And so it could be easier, it could be harder. So.
There was a system that the university used to have. I don't know if they have it in the main campus. It was called CASA.
Mm-hmm.
And this was on the math area.
Mm-hmm.
And basically, throughout the semester, they created these blocks of instruction. And the student will go online, and he will start the first 2 weeks. Well, pretty much it was on a daily basis. But the blocks were designed to be maybe every 2 or 3 days.
Mm-hmm.
That you will take a quiz online with the time setting. And the quizzes were different every time.
Mm-hmm.
And I think that at the end of the quiz, you will see your results.
Mm-hmm. So that's right. And so this kind of immediate feedback is supposed to be one of the advantages of this particular method.
Exactly.
Okay.
And I think probably in the area of physics, you have to do more manipulation of concepts. It's not a straightforward answer. Well, math is still the same thing. So math application. But you will look at how you did in a time constraint, 60 minutes,
Mm-hmm.
an hour. And you could take as many as you wanted to. So basically, you build proficiency interactively on the material that was being discussed. Instead of sometimes you probably do a homework and you study whatever is the time you have to, but you don't become proficient in building your skill in that area.
You've hit the nail on the head. Yep.
And I think that's one of the problems that we have in math departments and in physics application is that the students are not building proficiency, time-based. Because I think I find out that it's not what you know, it's how fast you can do the problem. And if you can build a problem within a certain time, that makes a plus added to the knowledge that you already have.
Okay, so you're right. I mean, there are systems that are similar in some respects to this. I've had more than one publisher try and sell me their online test grading or homework grading service. I tried one maybe about 7 years ago. It was such an awful experience. I blocked out of my mind what company this even was. What drove the students crazy, and of course then they would drive me crazy about this, is they would go ahead and solve the problem. Even when they solved the problem correctly, if the number of significant digits wasn't exactly what the program said, then they would, they would get the problem wrong. And then they'd come to me and say, well, I've solved the problem using everything that you told me. Why is this wrong? And then, we would have to figure out, okay, well, instead of 4.00, you put 4.01 because you rounded something. And personally, I don't pay a lot of attention to that sort of rounding. So the program was so kind of particular about how it graded that it became useless. And so I think, that's right. For physics, that is something that I don't know that they've actually solved yet. So you can go ahead and, I know, kind of set the tolerance of an answer to be within 10% or something, but sometimes that makes sense, sometimes it doesn't make sense.
Well, the key was don't make the answers too close to what the answer is.
Yeah.
I mean, give it this distance, because when you do math or do application of physics, you will know what the answer is in that proximity.
Yeah. The other thing I think that I wanted to just say kind of about this particular system I think that you're referring to is that if we look at this last problem, okay, on a level surface, it's kicked in an angle of 50 degrees above the horizontal. You have an initial velocity of 30 meters per second. What are the components of the position? Okay, if the automatic homework service is trying to generate a random problem like this, then probably what's going to happen is instead of 50 degrees, maybe it'll be 40 degrees. Instead of an initial velocity of 30 meters per second, maybe it'll be 20 meters per second. It'll be the same type of problem. On my test bank, I'm not changing that. I'm changing the last thing. What are the components of the position? What are the components of the velocity? What's the magnitude of the velocity? And so they're learning to kind of read the problem to understand what it is that I'm asking for. So it's the same type of problem, but now the answer can come in all sorts of different forms. And that's going to be true of all the different problems. Do I want components? Do I want the magnitude and the angle? Do I want something else? And so you could get that ideally from an automated service. With this, it was very easy to set up. Yeah.
Students with accommodations, tell you in advance, so you receive accommodations. You see like an increase in students coming into your class with needed accommodations. You see improvement like in the data, or just people expressing to you that they appreciated the changes.
Okay, so the accommodations, I guess, means a lot of different things. I mean, some of my students have accommodations, but they really don't ever need that because they're able to do the quizzes on their own within the 15 minutes. A couple of the students, though, do use the kind of testing center religiously, and so for them, one of the things they have to, in order to be eligible to use this, they have to kind of present their documentation at the beginning of the semester. An email from the testing center saying this particular person is authorized to kind of use the facility. When they make an appointment to take a quiz, then I'll get an email about that saying, this person's come in, they'd like to take quiz number 2. Can you please send us a copy? Which I'll go ahead and do. And then one of the things that happens when I get everything back is they will actually record how long the student took. And so this one particular student that's kind of finishing up successfully now this semester, I mean, he's normally taking about an hour or so to do each of the quizzes, which is fine. So, and he'll take the final, and so, he will have the time that he needs. But each of the students is kind of always slightly different. But if they feel like they need it, then they have that option available to them. And I think they do appreciate that. Yeah.
I was just curious about, have you noticed anything in like the variation in students, quiz breaks throughout the semester?
Well, okay, so that's a good question. And this is going to be kind of a generalization, but I mean, there are definitely some students, and these are probably the older students, who are really good. They'll kind of block out some time to take some quizzes every week, and they'll try and stay current with the material. There may be a week or two where they, take fewer quizzes than normal because something else is going on, but they'll normally make that up. There are also going to be, a few students, more of the first year students who are reveling in the freedom of college life, and so they're not used to doing this. So this is very different from the way high school was taught. And so sometimes, as we know, too much freedom can lead to unintended consequences. So they may feel like, okay, well, things are going fine. I'll take my first week quiz after a couple of weeks when I've had a chance to really understand the material. So by the time a couple of weeks have passed, the quiz is closing. They may only have one shot at it. Or things will go fine, and then suddenly the organic test looms and everybody kind of fixates on trying to pass that test, and everything else, is ignored until the danger is past. So there are going to be, I think, some population of students that I have to kind of reach out to, and especially at the beginning of the first semester. So this semester, they've been through this before. Everybody kind of knows what the drill is, and things are a lot smoother. In the first semester, where maybe students haven't heard from other students who have used this particular method, you just, there's the nickname of Southwestern is Mouthwestern. So everybody talks to everybody about everything. So students in my class will talk to students who have taken this class before. And so there's a lot of informal advising about, what's the best way to kind of set up your time. Okay, some students aren't going to have that benefit, especially kind of incoming students. So they're kind of especially at risk. So one of the things I try and do early in the semester is we'll have the group quizzes in class just to get the students to take any quiz. So once you kind of have taken the first quiz and you see, oh, it's really not that scary, then it's easier to take the next quiz, especially because once you get the quiz back, then you can use that to kind of as additional practice material. What most of my students do when I hand the quiz back is they'll go through it. Okay, what did I get right? What did I get wrong? Sometimes they'll come and talk to me after class. Can you explain why this was counted wrong? And so we'll talk about it, and they'll say, oh yeah, okay, well that makes sense. And so then they'll kind of schedule a time to come in and take the quiz again. So by having lots of opportunities to test themselves on the material, then they are engaging with all of this to try and understand it. And then, as you kind of all know who have taught physics, it all builds on itself. So the more that we can kind of get the first couple of weeks under control, understood, then it becomes much easier then to take that knowledge of two-dimensional vectors, three-dimensional vectors, and then start talking about two-dimensional forces and how all of this comes into play. So to answer your question, yeah, there are a couple of students. There are some students that traditionally I think need to be encouraged to just get off their butt and give it a try, even if it's not their best. Because once they've done it, then it becomes a lot less threatening. Well, and that's the other thing too, is as over the course of both semesters, There's always going to be material that some students find to be kind of much easier to pick up, and then some that's more kind of difficult, more conceptual. And so as we kind of move through the different topics, so we start off with 1- and 2-dimensional motion, then we move to forces, then we move to work and energy, then we move to momentum. A lot of times students, yeah, I mean, they'll understand, you know, where they would have had problems in the 3rd week, suddenly by the 5th week, yeah, forces make a lot more sense because maybe it's a lot more kind of used to how they're thinking about everything. That's me. I really should shut this off. And so, okay, done. So yeah, and that's the other thing too, is it's, you know, just you have to keep up with the material, but especially this semester, so we start off with kind of really the worst part, electricity, electrical forces, electrical potential, and it is just so conceptual, so different from what they're used to. It's talking a whole different language. By the time we get around talking about optics and waves, everybody, oh yeah, they can kind of see how kind of maneuvering everything in front of a lens, in front of a mirror makes sense. That's something that's being reinforced in lab as well. And so the test grades for those weeks are kind of routinely higher the first time somebody will take that. But yeah, there's going to be things, you know, if you're taking a quiz over the electric potential, then maybe you really understood how everything fit together. Maybe you didn't, but if you've taken the quiz, then you kind of start to say, okay, well, I understood this, I didn't understand that. But then we can go back and we can take a look at the notes or bring it up in class and try and figure out what it is. And that's kind of, I think, to answer your question too, it's kind of, it's important to identify what it is that we think we know, but we don't actually know.
And like you're saying, maybe if they were able to, once you finish a practice quiz, you can look at the answers and see where you did it wrong, all online. It doesn't have to be directly giving it to you. It can be online and then see where you made the mistake and make the correction and then take another quiz.
In an ideal world, yeah, it would be great if you could do this online. But as I mentioned, I mean, just my exposure with the state of the art is one of the reasons I developed this. Because, like I said, this was doable. This did everything that I wanted to do. The kind of the big difference, I guess, between the online and this version is when they're done, they have a physical copy that they can put in their book to then use to study for the next quiz. If it's online, it's a bit more ephemeral.
Well, I know the University of Houston had it for the math department, but I guess looking at the physics because it requires more articulation. But it could be, I can't see any problem in that.
I'll definitely check a little bit more into that then.
Casa,
Okay.
the main campus.
Okay, thanks.
Any other questions? All right, let's thank our speaker. All right, so I've got the sign sheet was floating around. Back here. I sent you guys an email reminding you about course evaluations and also about if you have any outstanding assignments. I need to get those by next Monday. Now, what I would like to do is we could shut this down. I'm going to shift gears and I want to actually show you, talk about what we have to do next week for our seminar, for the final talks. So I want to actually kill the recording on this. Yeah, I can. I just need to. I'll be there. I'll be there.
Leave now so you have time with your students. Thank you.